So let's scroll down so we can actually try this concept of an absolute percentage error. So there's the formula. It looks just like before, but with an absolute value sign around the error. So just so you know how to handle this, the absolute value of a positive number is simply a positive number. Nothing changes. But the absolute value of a negative number, we turn it into a positive number. So you can think of the absolute value sign as being something that keeps the positive contents of the absolute value symbol. We keep only the positive, the magnitude of it. Alright, here's an example then. Let's find the absolute percentage error if a profit of 1,367,540, so that is our exact value, and here is our approximate value. So our absolute percentage error, I'm going to abbreviate this if you don't mind. My absolute percentage error is going to be, alright, our numerator is the absolute value of our error, and you remember that our error is a little higher, there it is, VA minus VE. So our approximate value, 1.37 million. Now then, I'm going to write that out as a regular number. There's my 1 million. And then there's my 0.37 of a million. So hope you can see this, that I've got 1.37 million. Alright, just a little bit over 1 million. And from this I need to subtract my actual value, the exact value, which is alright, I'm just going to get this out of the way. 1,367,540, and I'll close my absolute value sign, and this all goes over my actual value. It's the exact that goes on the bottom. Alright, this one here, the exact, goes on the bottom. And so that's going to be 1,367,540. And at the end we'll multiply it by 100% just to make sure it's converted into a percentage. Alright, here we go. 1,370,000 minus 1,367,540. So my numerator so far is, well, look at that, I'm lucky. It's a positive number. If this had been a negative number, the absolute value would force us to keep only the positive contents. So let's just pretend that this had been a negative 2,460. We would, as we continue our calculation, have to change it into a positive 2,460. Alright, let's divide this amount by the denominator of 1,367,540. And lastly, we will multiply by 100 so that we can convert it into a percentage. You can see that we get 0.1798. Okay, now we always want to round to 3 significant figures. So 0.1, well, let's think about this, 179. That's my third significant figure. So I need to cut off after the 9. Well, my 8 that comes after the cutoff is 5 or greater. And so my 9 is going to round up. Well, I can't put a 10 in there, so let's look at the next digit. 79 will roll over. Remember your car odometer? 79, if it has to increase by 1, will go over to 180. So 0.180. And I do need this 0 at the end to demonstrate that I've rounded to 3 significant figures. And remember that it's a percent. So 0.180% is the absolute percentage error. And the last comment at the bottom, sometimes it is better to estimate rather than measure. Look, I know that if you were to measure as precisely as you could, you'd probably get, of course, a more accurate measurement. However, it's not always feasible to measure that accurately. For example, what if it would take you 20 years to measure something accurately? Or even if it takes you 20 hours or 20 minutes, maybe you don't have that kind of time. So that's one time where you might want to estimate your values before you calculate them. Just to remind you what we're talking about here, I'm referring to a problem like this one. If these were your true measures, 38.7 and 5.1, but what if it took you a really long time to measure them to that degree of accuracy, and yet you could estimate them quickly with a 40 and a 5? That would be a time where maybe it's appropriate to estimate. Another time it might be appropriate to estimate instead of measure is if it's incredibly difficult to take the measurements. What if these measurements are located at the top of an incredibly tall building and you would risk your life by going up there? Perhaps there's a way that you could estimate those measurements instead of having to go through the difficulty of measuring them precisely. And the degree of accuracy needed. Look, if we don't need a super accurate number, well then maybe it doesn't matter that we estimate the numbers that we're going to be operating with a little bit. But if you do need a super precise answer, well, then you need to be really careful if you're going to do any estimation at all. So generally, we would ideally like to measure and be dealing with the exact values, but here at the bottom you see there's 3 times where it would be quite appropriate to estimate rather than measure as you calculate a quantity.